find the limit. The limit, as x goes to 0, e to the x minus 1 minus x divided by x squared. If we try the quotient rule, we'll be taking the limit e to the x minus 1 minus x as x approaches 0, divided by the limit x squared as x approaches 0. And so both the numerator and denominator are continuous functions. We can calculate their limits by substituting in the 0. So 0 minus 1 minus 0 divided by 0 squared. E to the 0 is 1. 1 minus 1 is 0. And 0 squared is also 0. So we end up with the indeterminate form 0 divided by 0. That tells us that the quotient rule fails. However, because we have in our original limit, the numerator and denominator are both differentiable functions, we can still try to use LHopital's rule to evaluate this limit. So remember that LHopital's rule says you can take the limit of the numerator divided by the limit of the denominator and evaluate the limit that way. So the limit as x goes to 0. The derivative of the numerator is e to the x minus 1. The derivative of the denominator is 2x. If we try the quotient rule here, the limit of e to the x minus 1 as x approaches 0 divided by the limit 2x as x approaches 0. These are both continuous functions. So e to the 0 minus 1 divided by 2 times 0. E to the 0 is 1. 1 minus 1 is 0. 2 times 0 is 0. Another indeterminate form. So our quotient rule fails yet again. And in fact, at this point, our LHopital's rule has failed. However, notice that we have made things a little better because the denominator used to have a power of 2. Now it has a power of 1. So the power of x has gone down by 1. And so maybe if we try LHopital's rule one more time, that denominator will be completely rid of the factor of x that's causing it to go to 0. So let's try LHopital's rule one more time here, which we may do. So by LHopital's rule, again, on the previous line, we have the limit as x approaches 0. The derivative of e to the x minus 1 is just e to the x. The derivative of 2x is equal to 2. Now if we try the quotient rule, we have the limit of e to the x as x approaches 0 divided by the limit of 2 as x approaches 0. This is e to the 0 divided by 2. E to the 0 we've said already a couple of times is 1. And of course 2 is 2. So we have found by using LHopital's rule a couple of times in a row that our original limit is equal to 1/2.